recording.
I think I'm not on mute, Lita, but just in case. There you go. Okay. I think I'm off mute right now. I don't know if you can tell or not. And operational excellence. But enough about me. Just to give you a little bit of info on what we're going to cover tonight, I have a lot of bullet points up there. I'm going to do first a brief primer on Puppet. I don't know how many folks here have used Puppet, but show of hands, anyone here use Puppet? Right? We're Microsoft. We're in Microsoft, right? So, so that said, what's that? Yeah. I'm gonna do. I'm not here to compare necessarily Puppet to Puppet to DSC, but I do want to show this in light or compare and contrast a little bit. I'm not, there's no argument here, no religious wars about who's better, who's worse. Just to set the tone on what or how Puppet works compared to DSC, that might actually help some of the concepts. So we're going to go through a number of examples with the PowerShell Provider in the exec statement, which is sort of like the script resource in DSC. We'll show how to embed PowerShell and Puppet with defined types. We're going to look at the Chocolate Provider. So I think 2 presentations ago, Derek Morawski presented Chocolate here. We're going to see how Chocolate can be used with Puppet, so you can have your Chocolate packages, as well as now, not only do you have Chocolate packages, but you can also use them from Puppet and install them from Puppet, right? We'll talk a little bit about what Puppet calls custom facts. This is used in the sense of configuration data, node configuration, classifying the device, not just by name, but by something about the devices. Like this is a web server role, this is a SQL server role, you might do something different depending on the role of the server. We'll look at Puppet and DSC integration, some different ways you can actually take DSC and hook into Puppet and execute DSC from Puppet itself. Custom modules, doing a little bit of mishmash with Ruby and PowerShell. Underneath DSC, of course, is PowerShell, right? But under Puppet, you have Ruby. So we'll do a little an example of showing how we can actually use both languages to configure Windows. I'll also go through some custom PowerShell modules. These are modules that I wrote to help with the automation, and we're going to see a lot of different techniques there. If we have some time, I'll cover a little bit about PowerShell workflows. I don't know that, Leo, if you've ever covered the PowerShell workflows here.
No, we haven't really touched on that.
I did a little bit of work with it, and I figured a little something extra to throw in that isn't necessarily with the tool set, but there's some interesting things that might come out of that we can discuss. Awesome. And you know, so while this is focused on showing PowerShell integration with Puppet, hopefully some of these techniques in general might spark other ideas that you have, where we can, you know, discuss some other scenarios you guys have been through and share ideas. So, without delaying much further, just a quick primer on Puppet. So, Puppet was developed in 2005. PuppetLabs started out in the Linux servers, and in 2011 started to support Windows. Okay. Now, since this originated in the Linux world, of course, support originally was for Linux. So you have a lot more resources than Puppet supporting Linux, but the support for Windows is getting much better, especially in the last year or two. So there's a lot of good modules out there that we can use, and we'll see a theme here is, you know, we might be able to find something that does something for us already instead of building it, but we'll talk about building as well. So, and similar to DSC, you use Puppet to describe your desired configuration and you apply it. You can do it on demand, or you can set it for a schedule. Every 30 minutes is the default for Puppet. It provides a declarative language to state your configuration. It's a DSL or domain-specific language. And the different components of Puppet, we'll look at, again, high-level Puppet Master, Puppet Agents, modules, classes, resources, types of providers. I'll do a little bit of analogy between DSC components so you can see where it fits. And Puppet also provides a lot of orchestration in being able to configure your systems, really clear, powerful linking and dependencies within Puppet itself. Okay. All right. Other things about Puppet that might be interesting. So, you know, Puppet can be used in both Linux and Windows environments, as we talked about. Puppet's also been integrated with VMware, Amazon Web Services, Cisco, F5 load balancers. You can actually configure those types of devices with Puppet. Okay. And just to give a little bit of comparison, okay. So I'm going to start with the DSC example.
Can you guys see that, or should I turn the lights down?
Yeah. So just as a point of reference, if you've been using DSC, look at the examples. This is really just one of the examples from one of the waves. This is configuring a demonstrate or a website, a sample website. So to structure this, you have parameters. Obviously, you have node information here, what node is going to be configured. We have different resources. We have Windows features, website resources, excuse me. And then, for example, this here is configuring the default website. We can see the properties that are being passed to it. File resources. This is key because we're going to see some analogies in Puppet and give us the basis. So this is configuring a couple websites, a default website and a new website called whatever the website name passed in. Okay. So DSC, if you're familiar with it, this is what it looks like. Now, a analogous Puppet script using some of the tools from the Puppet Forge, which we'll talk about, which is where you can get modules, like a repository for Puppet modules. This is doing something similar. It's not a direct analogy, but you can see the DSL here is specifying that we have some app pools that we're configuring, same kind of format we pass in the parameters that we want. We have an IS site called Puppet IS demo, the port that it's on, the bindings, et cetera, et cetera. So there's a lot of analogy between both Puppet and DSC in this case. Both of them provide this language that you can specify how you want to configure, not, or what you want to configure, not how you want to configure. Any questions so far? Okay. Just, we'll get off the primer in a minute here, but one more visual comparison. I'm a visual guy, so I like the visual comparison. So how does Puppet work compared to DSC, right? So we have Puppet Master in Puppet world. We have the tool server in the DSC world. This is a very oversimplified example, right? There's a lot more going on under the hood. But essentially what happens, first step is in the Puppet side, scripts are authored, they're stored in the Puppet master. On the DSC side, you create your DSC configuration, you put them on the pool server. The agents in Puppet will tell the Puppet master, hey, I want a configuration, and it pulls down a catalog from the Puppet master. On the DSC side, the LCM, the local configuration manager, will query that from the pool server, pull it down, okay, in a MOF format, the managed object format. And then it's, in both cases, again, the responsibility is either on the Puppet agent's side or Puppet agent or the DSC LCM to take that and configure it. There's some reporting that happens in both cases, and that's pretty much the oversimplified look of this. So a lot of similarities that we can see, but there are some differences. Well, we won't go into them too much here. Okay. A brief note about the Puppet Forge. I mentioned this, but if you need to do some kind of configuration in Puppet, the first place you want to go is the Puppet Forge. They might have a module there for you that you can use and install in your Puppet Master to do what you want to do. So why reinvent the wheel? That's the hint here. And you can get it at forge.puppetlabs.com. There's over 3,100 modules available. Okay. And just a brief look at the Puppet Forge. So you come here, you can search. Actually, this increased from 5 from yesterday, but I can do a search, for example, on IIS. You can see there's a lot of different modules, even for IIS, that contributors have provided. Some of these have this approved little tag here. There's also another one, I think it is, I forget, it's actually a green tab, I forget the name of it, but this one actually, the approved ones, and supported. So approved means that it's passed some rigorous standards of testing, okay? And it's a pretty good module by Puppet standards, where as supported means not only is it approved, but it's actually supported in Puppet Enterprise. So Puppet comes in 2 flavors, Puppet Enterprise and open source Puppet, okay? So this is where you go to look and find any modules to do something before you go try to build one yourself. All right, so let's have some fun with seeing Puppet in action. Any questions, guys, before we go on? All right. So, the exec PowerShell provider. So if you've used the script resource in DSC, right, you do that because for typically, not the only reason, but typically you have a script that you want to reuse, or there's a resource that doesn't exist that do what you want to do, so you write a PowerShell script and you plug it in, right? You do the same thing in Puppet. What can tend to happen is whether you're in DSC or Puppet, it's no longer declarative, right? It's sometimes harder to see then what you're trying to do because you're looking at a script that you're executing versus a very nice concise statement that says, I want this website, it has this name, here's the path, here's the app pool it belongs to. Okay, so, but sometimes those are necessary. The provider was created by Josh Cooper of PuppetLabs. It's available in the Puppet Forge. And it also provides a concept called idempotence, the ability to run something, again, without changing the effect of it. Right? So if anyone here ever create a script and you build it, you're happy and you run it, and then you go to run it again and it behaves differently? I have, right? So the concepts around Puppet and DSC about idempotence is having something that can put you in the configuration state that you want, but you can continually check it and only run it when you need to actually run it, right? So DSC has a similar mechanism to hook in, and in the Puppet world, there's a couple parameters, creates only if and unless, and this lets you, we'll see an example of this, but lets you specify the conditions in which you actually execute the script. Okay? So it's a little bit smarter way to say only run it if. Okay? So before the PowerShell provider, Puppet really only executed things at the command shell, like batch scripts or CMD scripts. Okay. If you wanted to execute the a PowerShell prompt or PowerShell script, you got to do a little bit of magic with specifying it. Okay. And let me show you how that looks. Okay. So here's an example of executing in Puppet. This is a very simple example. We have an exec. This is the resource type. We're calling it rename guest, and this executes, as you can see. I'm going to unhighlight that so you can see a little more clearly. We're actually calling the PowerShell interpreter, and we're passing it execution policy. We're calling it the script. Now that's not very descriptive, right? We think we know what it does, but we're not really sure. Okay. Whereas this gets us a little better. It's not great, but in a pinch, we can work with this a little better. These two do the same thing, but you didn't know from the first one what it did because you're just calling a script. So this actually is an example from Josh Cooper's page in the Puppet Forge for this, but the gist here is renaming the built-in guest account. And we essentially use WMI to pull out the guest and rename it. If we did that first time, that would work, right? If we did it the second time, it'll probably fail because we already renamed it. But if someone goes back in and renames that account back to guest, it's changed configuration, right? We really want to enforce that. So that second part there, unless, helps us with that. And before it executes it, it actually runs that second script that says, hey, if the guest count, if the guest account is actually there, then run the command and fix it, rename. And then we specify that we want PowerShell in this by using the provider attribute. Okay. Another quick example of how we can use it in a little more complex manner. Let's say we can actually use other PowerShell modules, right? So we can write strict PowerShell. We can actually call PowerShell full scripts if you wanted to, just like that. But we can embed it here. And this is an example where COM activation, right? COM plus objects and COM plus the whole activation, distributed activation and security piece. No one's really writing this today because it's a little bit legacy, right? To some degree. So there were some components out there. This actually is a component called Carbon. And there were modules in there that actually let us work with some of the COM components on that we needed to. So in this case, I have a few of them together. Again, you see the structure. We import the module. We string it together with just a semicolon to do that, and then call the individual commands, and we have the conditional execution of that. Right? It's a little more complicated example of this. And again, these are execs. You can look at the code and get an idea of what it is, but just keep that in mind because we're going to look at other ways to do this sort of thing. Okay. So what are some other ways that we can use PowerShell? So a few of these examples I'm going to show, they're doing the same thing, different ways. I'm doing that purposely because I don't want the result to change. I want to show you that there's different ways to use different techniques to do it. And we're going to progress into different ways to achieve the same results using PowerShell. So define type in PowerShell is if you need that resource to change something in IIS, for example, that doesn't exist, you can write your own from DSC to write it in PowerShell, right? In Puppet, you could actually use the Puppet DSL. The DSL is not a full-fledged general-purpose programming language, but it does have some constructs for things like conditionals, booleans, case switch statements. There are some basic types, regular expression matching. So it's a basic language, but it doesn't do what a full-fledged general-purpose programming language like PowerShell or Ruby would do. Okay, but it can get us to a certain point where we can create a type and hide the complexity of a bunch of exec statements. And it can help you with the over-execing, what I call it, over-execing, right? Too many, it works, but it doesn't look that great, and you really can't see the structure of your configuration. And in this case, we can use native PowerShell. Okay, so I'll show you an example of a defined type written in the Puppet DSL. Okay, so in IIS, I just picked on this one example. So we go into just at the server level here, in IIS, and we go to alpha caching. Okay, default configuration for this is essentially having both the enable cache and the kernel cache enabled. Okay, so there's nothing in Puppet or PuppetForge in the core library or PuppetForge that really just tweaks these two parameters. Okay, so let's show you how you can write one to do that. So I could do a script, an exec, and not really have it documented, or I could do something like which is this. Okay. And when I run it, okay. So I'm not connected back to our network, so I have Puppet, everything Puppet local here. It's the equivalent of running DSC without full server, just running it locally, Puppet apply. Okay. So I have modules installed locally, and I have the configuration script. So I'll run this. So again, my goal here is to take this and disable this. And right now, I have a bunch of examples which will uncomment as we go along. But right now, these are the two that are going to be executed. So I named them disable server caching or disable kernel caching, and the same pattern we've been using. In this case, I import the web administration module. Okay, that gives me access to the IIS API, for lack of a better phrase there. And I use the set web configuration property and get web configuration property commandlets to manage those individual parameters within IIS. Okay. Okay. And what we're going to see next, this will take another 30 seconds. A little slow in this box, unfortunately, so I apologize. Just give that a second. What we're going to see next is how we can make that a little neater. Okay, so we're done here. Let's take a look. I'm just going to refresh because let it repull from the configuration, and it's been able to disable those. Okay, so I had a very targeted, it's a very simple example, but using PowerShell and Puppet, I was able to target the tweaking of those particular parameters. Okay. All right. Let me just reset that real quick. Back to that. Okay, so I'm not happy with that. So what I can do, what if I could do this and have a much nicer way to express that? Okay. I think that looks nicer than those two big chunks of code up there because I can see what it's doing a little more clearly. All right. So if I go back here, I've reset this, it's back on. And I will run this while we're talking. So on this one, I built this so that if you specify the application hosts, this is a predetermined string that knows you're going to do it at the site level or the server level. But you can also pass in a site name, so it's configurable at this point. And it's very basic. We have the values of the kernel cache and user cache either false or true. So how does this work? It's this right here. Now, you might say this is ugly, and it might be. But the point here is that we've hid this complexity from the user, right? So we've taken the Puppet DSL and we've written code in the DSL that achieves the same result and lets the user specify their configuration in this very simple state. So a quick tour of this. we have the type that we define right here. You'll see that this is actually the same name as the type in the other file. We have some parameters that we've described that we're passing in. The kernel and user cache, we have some validation of the parameters. We can do some checking on that, making sure that we're only passing in what we want to have. Again, I mentioned a little earlier that the DSL is not really a full-fledged programming language, so it looks a little kludgy in some ways. So you might ask, well, why didn't you write a nice case statement? Why didn't you do it this way? Why didn't you do it that way? I've done it actually a couple of different ways with some nesting and other things. Case statement didn't work for me in this case, pardon the pun. But this basically works, and I go through all the conditions to make sure it was a small enough set that it didn't have an unwieldy amount of cases or conditions, right? So what am I doing here? Well, you can see the pattern. I'm really just looking at what my user is passing to me and executing my PowerShell, just like we've been doing. Okay. Only the slight difference here is when you do a defined type, you may notice some of these variables in here. So Puppet does have variables specified through a $sign here, and that's so we can handle unique naming as Puppet runs. You want to have a unique name for your resources. Okay. So if it's application host and default host, you want to have, if Puppet sees it, as two distinct different types of configuration. Otherwise, we'll plot. Okay. So that got done running a little bit ago. Now if I refresh, and we won't necessarily do this every single time, but just to show you. Now it achieves the same result, a lot cleaner. Okay. Questions? All right. All right. So let's move then to some of the PowerShell DSD integration you can use. We can do it a couple different ways. We can execute a DSD script directly as if we were running without a pull server. Okay, so we have a configuration script, we can execute it. There's also, in the Puppet Forge, a Puppet DSD module. I'll reference, I think the last gentleman, Stephen Morosky, was it, from Chef Labs, or Chef Software. He, I think, showed that they had a mapping of DSC resources to Chef, right? This is a very similar scenario. Right now, it's behind. It's only at wave 6, but it's open, so you can rebuild it with the new waves and map it in. So we'll see an example of that. You want to use it. If there's already a resource that works well and you need to use it in Puppet, then you can have that mapping directly. So let's jump to an example of that. So let me comment this one out. All right. So this one's a very simple example, again, but shows you the mapping. I don't remember the prefixes that were in the Chef software example, but again, you can see what this is, the mapping of the DSC file resource. We want to ensure that this is present. It's a directory, and the directory name is DSC test folder, right? So right now, it's not there. Okay, we'll run that. This will create it. We'll let that cook, and we'll talk about the analogy here, the analogous expression you might see in DSC. And that's right below it. I'm not going to uncomment this because that'll mess up the run a little bit. But essentially, you can see the mapping. So the only difference here is that it's prefaced with DSC, and that's a direct mapping. So the way this works under the hood, the way the author has developed this is it's built in Ruby. He uses the MOF generated from DSC and is able to build that mapping through the MOF. All right, so now I should have my DSC test folder, and that's been created, just with the mapping of DSC. Okay. All right. Okay. Here's a little bit on the, that was the first way we can do. We can have, one of the ways we can map it using the DSC Puppet module, which maps it. We can even build our own DSC resource. Okay. So I've built one for this example. Making sure I got the right one. Here, by the way, this is also from Mark Sutter. This is from his GitHub and Puppet project page. You can see a lot of the other mappings. There's mappings for the Windows feature, although Puppet has itself, it has a Windows feature as well. Website, so you can see that kind of mapping in action. But here I have my own DSC resource I wrote. So this is execution of that, and this case we're doing the same thing. And if I look at what's behind it, so I'm executing it, but here's the code behind it. So I think you guys have seen in a couple other previous presentations how to write the DSC resources. A couple of the key things you need, and this is going to translate a little further when we look at a Puppet custom resource, but you really have three main hooks into a DSC custom resource. You have a method that essentially retrieves your configuration that you're interested in. You have another one, and that returns essentially a hash of those key pieces of information that you want. There's a test target resource, which compares it, the state that you want to the state that you have, and returns a Boolean true false. And if you need to set it, then you have the set target resource and you pass it in. So that's what I've done here, using the built-in, the designer that creates the structure for me, and then plug in my code for that. But if you've seen the previous examples, what you notice here is I'm using a lot of the same core PowerShell, right? So I've been able to take that one step further and start to use, I'll import the web administration module, and then I'll start using the existing PowerShell commands that are able to talk to the API and pull out my configuration information. Okay. That's really the meat of this. PowerShell, when you do the designer for the DSC resources, it will nicely create, you specify the parameters, and if they're read-only, read, and they're key values, and it sets up the nice functions for you, and then you plug in the code here. So that's how this piece works. That lets me, this is a script I wrote to use that DSC resource. So again, this part is hidden from the user. We can expose this part to the user to just have a very, sorry, my mouse keeps jumping on the bottom and hitting the those pieces that pop up, or the folders. But we can expose this to our users and let them configure very simply. And then in order to run it, we can simply call it like that. Okay. I want to execute this when it does really the same thing, unless you really want to see it, but we can now directly call any PowerShell that calls a DSC resource. Any questions, guys? All right. I already got that one commented. Okay. Okay. Now this one, let me jump back here. talk a little bit about my custom types and providers in Ruby. So just like we built a custom DSC resource, we can build the similar type of component in Puppet. Now, we did the DSL, we used the DSL before, but if you want to get a little more advanced, in some cases you need to use Ruby to do that. So the next example I was showing you is written in Ruby, and we integrate a little bit of PowerShell because Ruby doesn't have some of the, while Ruby is a strong language, it doesn't have the ability to interface with Windows as well as PowerShell does, right? So we sort of marry the two together and create a little bit of a new tool here. So again, written in Ruby, we're going to interoperate a little bit with PowerShell. Same reason you do something like this, the same reason we've been doing and progressing through, which is I want to hide the complexity to my users and let them make the configuration statements they need to make, and then let Puppet do the job. Okay. We talked Puppet DSL can do some things, but not everything, so we want to use the power of a general purpose language like Ruby in this case. And we'll jump right to an example. Okay. So I got this one. I will run real quick. I'll set this back, and I'll talk about the implementation. We'll let this one cook for a few seconds. Okay, so again, very nicely, cleanly specified in my Puppet configuration file. How do we do it? Well, we use Ruby. We have Puppet provides a lot of hooks, just like DSC does. You specify 3 chunks of methods that get your resource, test it, and set it. Okay. Ruby has a very similar, or sorry, Puppet has a very similar way to do it. We first have to define our types. This really defines the parameters and the properties that we pass in the init file here. Okay. So this output cache is defining the site parameter and the enable user cache property and the enable kernel cache property. So there's a notice property parameter. Parameter is something that's passed in that isn't associated with the configuration item on the server or box, whereas the property is. So that gives me my definition of what that looks like when it's called. But now we have, and I'll expand this in a moment here, but we have a similar construct. So to do this, I essentially borrowed a little bit of code from Josh Cooper in this case, in the sense that the way the PowerShell exec provider works is you specify your PowerShell. If you're going to do an inline PowerShell, it takes that code and writes it to a temporary file and executes the file in a temporary folder. Seems like a lot of work to do, right? Why did it do that? Because what I've noticed, and here's what I think the reason is, but the escaping tends to get a little bit fun when you're escaping quotes and single quotes and things like that, right? So when you put it into a single file, your escaping problems kind of go away. Okay, so it's actually a much cleaner way to execute PowerShell from something like Ruby in that case. So there's a few different functions that do that, and I won't dig into them too much, but the write script, which writes it out, the run, which actually executes it. But the core thing of how the Puppet piece works, and Ruby, and how we're going to talk or add PowerShell to this, is these functions here. So we see some extra ones we didn't see in PowerShell. This is for the ensure. So when you say ensure this property either is present or absent, you have to define that in Puppet with Ruby. So first one is basically if it to test if it exists, and then if you want it to be present and it's not, you can create it. This is the method you would actually execute to create it and destroy, obviously, if you want to make sure it's absent. Okay. So this is just Ruby code here, and in order to create the output caching module, right? We use the managed web module components in PowerShell. Okay. So the general construct here is we define our PowerShell command, we run it, and then we look at the output and we can handle the output. So we get a little bit of the best of both worlds. We can poke at the APIs on the Windows side with PowerShell and get the response back and handle it and tie it back into Puppet. Okay. Now, these here are the equivalent of your setters and getters, or the set target resource and get target resource. The ones with value, these are the setters. They're basically the parameter that you would pass in, and the one without is basically the one that retrieves it. So it matches up with the property type. Okay. So what does that look like? So this one retrieves, and we don't really have a test resource like we did in DSC. This is sort of collapsed into the same function. So this one gets it, and then you compare that with the current configuration within that method, and you return either true or false there. So it's basically collapsed into one function. Okay, but same pattern here. We use the parameter passed in for the site, and then we can create a PowerShell command that either works with the application host. The PowerShell a little different if you're using the application host versus the website name, because it's a different location in the application host config. Ultimately, if you're using the web administration module, things work at different hierarchies in hierarchies in the application host config, so you have to account for that. This would be the case whether you use, if you didn't use Ruby, right? In this case, it's just PowerShell. So we run it, and then we do some analysis of the output, and we're able to return whether or not it's in the state that we want. And then in this case, if it's not in the state that we want, then it will automatically call the the setter method, which will set it. Okay. All right. Any questions, guys? So far? That one I think I forgot to reset, but what you'll notice here when I executed it, previously where we had the kernel cache change from true to false, here it actually didn't change anything because it was already in that state. Okay. So it's probably a fortunate mistake I made there. Okay. Okay. Talk about facts in Puppet. So every time Puppet runs, every single time, there's something called factor, which is installed with Puppet, that runs and gathers a bunch of facts about your device. Okay. Anyone here ever use the configuration data in DSC? Right. So I haven't used it much, Ludo, but if you've used it, right, you have to create that file. It's basically a PSD1, right? It's a hash of hashes. Yep. So you can create your facts about a machine based on the name, right? This server is a web server, and because it is, and it has, it's in my production environment, then I might set different values, right? So you sort of manually set out all your properties, your characteristics about the server and the configuration data, and you pass that in, okay? So with Puppet, you have factor, which out of the box comes with a bunch of facts that it knows about, okay? So all sorts of things. Host name, memory, MAC address, IP address, FQDNs, Ruby versions, where it's located, the Puppet version, all that kind of good stuff, right? So this is sent into Puppet, and it can be used to make decisions about how you're going to configure your devices, okay? Just like the configuration data from DSC. So that's what you get out of the box for free. And then we can extend that and make additional custom facts that we can execute every single time on runtime. And we can use a variety of techniques to find out things about the device, right? So let me show you this other example real quick. We'll go here. Okay. So this is one that so here's an example of installing Windows features, right, in Puppet. So we can do it in DSC with the Windows feature. There's a Puppet module for Windows feature, and we pass in all the individual feature names that we want, right? You can do it at the high level. In this case, we want to specify we want to be very exact here in what we're specifying. Now, for some of the similar configuration features that we wanted in 2008, they were different in 2005, right? For example, .NET 4.5.1 is now a feature in 2012, whereas you had to install it separately as an MSI, right? So where we detect, we actually want to handle that condition separately. So you can use this. So if the kernel release is a certain version, I'm using a regular expression, 6.1 anything, then that tells me it's Windows 2008. Okay? And in that case, I can install these sets of features. Else, if it's 6.3, it's 2012, and then I can install a different set of features. Now, some of these overlap, but here we get the 4.5 framework stuff. Okay? So we can use this to create more complicated and more flexible, not complicated not for the sake of complication, but we can handle a lot of complex scenarios, right? We want to handle the complex situation. We don't want to necessarily make it complex. So that comes from, you get these for free. So as you write your Puppet scripts, all these facts. So you can see here the kernel release was actually one of my facts. I can just leverage that right in my DSL script, right, my Puppet script, and I didn't have to tell the configuration file that it's a Windows 2008 machine, 2012. Okay, that's how facts work in Puppet. Very powerful. Now, we want to extend that. How do we do that? We can do something. Facts can be simple text files. Facts can be written in Ruby. Okay, and before Windows, it was Ruby, and they didn't support other They didn't support other Windows scripting tools or anything like that. But it does support, Puppet supports what they call external facts, which are not written in Ruby, but are written in some other language that you might find on the given operating system. So we can use PowerShell. And the key elements to writing a custom fact is to spit out a key value pair. Very simple, right? In this case, all I'm doing is, hey, if I see inetpub, it's a very simple case. You obviously would do something a little differently, right? But if I see inetpub root, it must be a web server. Okay. Otherwise, if I see the MS SQL folder, then it must be a database server. Okay. This is put into the Puppet master. It's run every single time and can give you a dynamic display of the facts. And if you look down here, this actually is running. And since I had a web server installed, it actually told me that this box is a web server.
So yes. I'm sorry, how often does the factor regenerate its facts?
Every single time Puppet runs, so whether you execute Puppet on demand or you have it on the default 30-minute timer, you can change that, of course. It runs. It's runs right before anything gets applied. The facts are gathered. It's sent. The Puppet agent and the master communicate over SSL, and there's certificates that are set up between the two. Pass it to the Puppet master. The Puppet master takes that information, builds the catalog, and based on those facts, because you then would actually use those in your Puppet scripts. All right. I have an example for this one. All it's going to do is spit out that it's, I'll cut to the chase, it's going to spit out, hey, you're a web server. Unless anyone really wants to see it, I'll skip that one. It's not very exciting, but it looks like this. I'll show you the code, that's interesting. and I'm sure you'll trust me that it spits out what it's supposed to spit out. Okay, so just like you saw in the previous longer script that's a functioning script, we have this which uses the role that I just created. So we have the role fact as a variable. And if it's equal to web server, then hey, notify it's a web server. Obviously, in the conditional, you do something very different, right? But that's the function of in a more we saw 2008 versus 2012. You might in a Linux environment, you might actually install a different package if you're running on Debian versus Ubuntu or something like that, right? So you can see all the different ways you can apply that. All right. Okay, cool. Chocolatey and the Chocolatey provider. Again, Derek Morosky did an excellent presentation. I watched it online. I didn't get a chance to be here for it, but on Chocolatey. Chocolatey's great. I love Chocolatey. Anyone here use Chocolatey on a regular basis? Okay. So Chocolatey lets you a package manager, right? I think it's always stated as sort of the author states it as kind of like apt-get but for Windows. So Chocolatey itself was written by Rob Reynolds. He's now a PuppetLabs employee. I think he's a fervent coder on GitHub and such. There's the provider, which lets you hook that Chocolatey into Puppet, and that was written by Rich Siegel. It's in the Puppet Forge. Okay. Chocolatey itself was originally written in PowerShell based on NuGet. It's been rewritten recently in .NET. It's a lot faster. Most examples of Chocolatey have you wrapping an MSI. Okay, have an MSI, and as long as you can figure out the silent install parameters, you throw that in, and it's got a lot of helper functions to do that. It's really nice, right? There's also a bunch of other helper functions that let you do really neat stuff with Chocolatey, okay? Like package a zip up. You have a zip file. How many people have written a script that takes a zip file off some kind of HTTP resource or URL, copies it down, and unzips it, right? It's pain, right? That's built into Chocolatey, okay? You can also do things, MSIs, I'm not a developer, MSIs are really, really kludgy for me to build. So you can do a lot of things. Matter of fact, some of the things that I'm going to show you what we did with Chocolatey is to create packages on our internal repo that don't require MSIs. You can deploy files, you can make all sorts of changes that you need to. Anything you can do with PowerShell, you can do in wrapping the Chocolatey and make it a package. Okay, it's really cool. So where we found that Chocolatey works really well for us, Puppet already has a package provider. So if you have an MSI, it actually works pretty well with MSIs. The package resource, and we go back to that idempotence word, right? Making sure that before you install .NET 4.5.1 in 2008, don't install if it's already there. So the package resource will actually look and see if it's installed. Looks in the registry and does also, I think it looks in the registry. But if it's in control panel, it's going to not install it because it knows it's already there. Where I found the Puppet package resource has problems is if it's not registered. If you have some kind of other installer that doesn't get thrown into control panel, sometimes installers that spin off and come back instantly while other processes run. So we've been able to use Chocolatey to help rein that back in and control it, so that we make sure that the actual installation completes, right? And the other thing that you get with Chocolatey is that it's idempotent, right? So once you install a Chocolatey package, it makes a reference on the system it's installed on, and you're able to, if you try to install it again, it tells you, hey, I'm already installed. Okay, so you get that with Chocolatey. let me show you a couple examples of using PowerShell and Chocolate together. Now, the reason I chose these two, because one is actually an MSI, whereas one is a completely non-MSI based package. Now, I'll show you the details of those in a few minutes. Okay. So syntax is very clear. We have package. We're ensuring that we have version 1.00 for each of those. Our provider is Chocolatey in this case. Okay. And the source in this case, because I'm local, I am pointing to a local location. Typically, if you have Chocolatey installed and set up, to point to either the external, if you wanted to use the external Chocolatey repository, or you have an internal repository. Okay, in our case, we're pointing to an internal one. We control it better. We can control, we create our own packages. That's part of our config, so it knows where to go. There's no question. But you could override that and send it somewhere else if you wanted to. Okay. All right. So, as part of our Puppet script, if we wanted to actually install these, the first one, as I mentioned, is just a, it's actually a zip file, but there's some other things going on, like environment variable additions. The second one is an MSI. This one allows you to extract the IP address from the HTTP headers or that come in if you're behind a load balancer. Load balancer acts as a reverse proxy, so you don't really get the real IP address. Okay, so most load balancers allow you to configure client IP or have that insertion. It's called X44 header. So this module basically extracts that and makes sure that it shows up in your IS logs. Okay. So run this. So Chocolatey lib is where the Chocolatey packages, once they're installed, where they live. Okay, we can see one just got added, the module got installed. Notice that the second one got installed before the first one. I don't have any dependency chain in here. So Puppet sees these two as equal packages, and sometimes they may pick the first one, sometimes they may pick the second one. But Puppet has a very strong chaining and ordering structure that you can link in there. Okay. So we see that it created that package, and let me, while that's doing this, I'll jump over to creation of that. Okay. So this might be a refresher for someone, Chocolatey. It's something that may be new. I think I saw a show of hands that some people may not be using Chocolatey yet, or maybe new to it. So when you build a Chocolatey package, there's a warm-up function, warm-up utility, which creates a skeleton structure for you. This is based on NuGet, which is a package manager that you can use to package things like libraries for Visual Studio. Sometimes developers use NuGet to share complete development libraries. You walk into a company and you're a new employee, you know, hey, for our product we use all these libraries, and by the way, we have all these already set aside, so you set up your development environment and just install all these and you're good to go, right? So Chocolatey takes it beyond that for the machine level. Okay, so essentially, you create your new spec file. And in this case, we have an install. We have an install and uninstall. Okay, this one's very simple, and this is the default way that most people use Chocolatey. We have a module name. We have the installer, which is MSI. We then have URLs and location. And in this case, our silent arg is very simple. It's /quiet. Okay, and then the magic happens with the helper function. Right here. Install Chocolatey package, specify the package name, all the parameters, and it magically works, right? So that's a nice thing. To uninstall this, do a little more magic. which is we have the package name, but then what we can do is we can start chocolate process as admin. That's another helper function. And we uninstall it by specifying the GUID of the product itself, right? MSIs, right, well, when they get installed, there's a product code, and you can uninstall even if you don't have the MSI originally. So this will actually let you uninstall it. Okay, so that's how you would. That's a typical chocolatey package. Okay, you can see this one's done for the firewall tester as well. Let's bounce up to. Sorry, I'm bouncing around too much here. Let's bounce up to the firewall tester. Okay, and let's look at the install uninstall on this guy. All right. This one, I don't have any MSI. I have a zip file, which is all these PowerShell module components I wrote. And really what it does, yes, I need the package name. I have a location of where this is going to go. And what I do then is I use some .NET to retrieve the environment variables. Right? If you're going to create PowerShell, so create PowerShell scripts and we put them somewhere and we have to kind of navigate to where they are, right? And then type them from there. So if you get into starting creating modules, you can package them up and then you put them into your PS module path, okay, as a module. And then someone installs that and then you just use it from wherever. You don't have to remember, where did I put that script? It's always in your system, right? It's packaged. So in this case, we're verifying whether or not my path that I'm putting it to is in my environment variable. If it's not, then we set it. Okay. And then if that's the case, we get done that, and then we use the zip package helper to take the zip package from a repository and put it down to where it needs to go. Pretty straightforward, right? Now, again, going back to our example, if any of you have had to script the unzipping process, I'd rather do this, right? It's a lot cleaner. The uninstall works a little bit differently. We have the install directory again, but and then we have this function to remove the module path environment variable. I'm going to pause. I'm going to roll that up for a second. But the basic logic here, is, hey, locate the path, remove that path. If you really want to uninstall the tool, remove the entire path, and then remove the PS module path if it's empty. So if you have this, and we have a standard directory that we create, and we create new modules, we create them there. So we may add 5 different modules that go into our path. We don't need to add that to the environment variable every single time because it's already there. So this logic here lets you verify if it's there or not, and then remove we call the remove PS module path. And this one has a little more logic to it because if you think about it, when you go into edit your any path environment, right? They're delimited by semicolons. Slightly different. I probably could have written this better, but this was easy at the time. If it's at the beginning of your path, you want to delete the path and the semicolon. If it's at the end of it, just the path, right? Because there's no semicolon usually, right? Or in the middle, you delete the path and the semicolon, right? So, and again, this is probably not the most elegant way to do it, but it works. But we use a little bit of .NET here to call set environment and get environment, calling some of that in there. Any questions, guys? Make sense? Fun stuff? Okay, cool. And just to show you I'm not a liar here, so this is done installing, and it's on my other screen right now. That's great. There we go. All right. All right. So we can look at get module list available.
I think module singular.
Thank you. Right. So down the bottom, kind of hard to see, but we'll see if we can zoom in here. Right. We got our PS firewall tester in there. This is the only PowerShell module, right? The other one was a package for an MSI, so that's not going to show up here, right? Okay. And then we can import that module. And this one just contains 2 functions, but done. Not done the presentation, done that work. All right. No worries. I did see, I haven't used it, but just there is apparently a chocolatey DSC resource available in GitHub. I don't know who wrote it. GitHub.com/evisionsoftware chocolatey DSC. So if you're interested in integrating that, I can't tell you from experience if it works well or not, but if you're looking to hook chocolatey into DSC, there is someone who wrote this tool for DSC. Okay. All right. So some more module techniques, and some of this is a little bit of showing extension. Extension of the PowerShell PowerShell modules, a few additional techniques that we use to do some things that we weren't able to do otherwise. So, you know, PowerShell module is essentially a collection of PowerShell tools in a singular unit, right? Sometimes they're written in pure PowerShell, sometimes they're binaries, okay? All depends on who's writing them, what the purpose is, if you need to execute it in a certain language, I mean, also and expose it as PowerShell. DSC itself is a set of PowerShell modules, right? And if you recall, our list modules, all our DSC modules are here. So the web administration has a few different commands in there. That's the concept of the module. So in our case, we wanted some tools that would help make Puppet a little easier to use on Windows platform. So we wrote some tools to help that. We have tools that check the chocolatey installation status on machines, you know, without having to log into every single machine. Over here, check the status of Puppet, install chocolatey, install Puppet. Other things such as there was actually the remove Puppet certificate came about because sometimes the certificates get a little messed up between the agent and the server. If you basically remove the client completely and reinstall it, or you re-image the box, the certificate from the agent is still with the master. So then there's obviously a mismatch, right? So in order to clean that, for example, you have to execute a REST API to remove it, and then you have to go to the server to delete it. This kind of combined 2 steps there. So that was exposed to a little easier to manage in that case. And then so I wrote some tools to query PuppetDB, so the reporting mechanism. So in DSC you have the compliance reports that come out. Puppet, as the agent reports up, it goes into PuppetDB. And there's many tools out there that read it, but I wrote one that queries it from the PowerShell command line. You can query information right there. So we're going to see some REST invocation. We're also going to see how we can write a PowerShell commandlet in C# and .NET. And I'll tell you why I did that. It wasn't just for fun. It kind of was for fun, but And the reason for these tools were really to create some mash remote execution tools. I call them near parallel through some fancy job execution and waiting and collecting and such. With that in mind, I'll show you a couple examples of this. Where was that? Yeah, okay. So we're going to install the Chocolatey PS Puppet Tools. And my source is going to be, let's see, let's check in the PS module path and see that it's already there, so it's not going to need to re-add a new one. Okay. Oops, that didn't spell it right. Okay. So install Chocolatey. I have a bunch of tools for us here. One thing you can do if you're writing your scripts and your modules, you can provide help for your users. Okay. So we'll do. Okay. So in this case, this is obviously very small, but we have more help here. But if PowerShell has this concept of parameter sets, right? So you have parameters that may not really work with one another, right? You can define these in your Puppet script. So this one, yeah, you can specify a string of computer names, an array of computer names, right? And you can cheat by, if you didn't want to have a link to a file, this one gives us a link to a file. You can cheat by using the first one and doing a get content, pass the servers in. But we wanted to make it straightforward there. But you can write full-fledged help. So these all contain full-fledged help and examples. And we can do that very easily. A few different ways to do it, actually. So this is the installation of this. I don't know, I mean, some people may be familiar with this or not, but you can embed your help right in the top here. Okay? That's certainly an easy way to do that. There's also, make sure I remember where that location is. So, or you can create a help file, right? Which is sort of a hard to do unless you have a tool like this. This is found in Coplex. Okay. Now, most of the original help I wrote, they were embedded in the script because they were PowerShell script files. Okay. So I'll load the module and it sees all these, and but then this one was a binary one, and you can actually use this to generate the XML. So I forget who the author is, but big kudos to the author who wrote this, because it makes generating PowerShell help files very, very easy. You can define individual parameters for this. This one just had a URI parameter. You can specify different examples in here, right? Links and things, all sorts of interesting things that you can build into the help there. Okay. Now, one of the tools that I wrote was this invoke REST Puppet DB. So we can invoke REST calls right from PowerShell with the invoke REST method, right? And it does a pretty good job. I found, though, that if you get a very large response, it kind of blows up. If your response is larger than 2 megs, before less than 2 megs, you get a nice PS object back with the parameters are deserialized nicely, and you get the parameters, the object. If it's larger than that, you get a big JSON string. Okay. Let's solve the problem by converting that from JSON, because PowerShell has a nice convert from JSON, right? That blew up a little bit because it couldn't handle a large file. There's apparently, I think, some hard coding in there to do that, to prevent it from, or that prevents it from reading anything larger than 2. In this case, I turned to .NET and C# and created a binary module that let me query it and handle both small and large responses and return back to PowerShell a unique, the same object, not a unique object, but the same object in the same format regardless. Okay, so what you can do, it's really cool. I was surprised that I'm not a developer, but I was surprised that through some documentation how straightforward it was. There's actually very few lines of code comparatively. A couple interesting things to point out more on the technique side, right? So you've heard a couple times Chocolate is based on NuGet. Well, I was able to use the JSON libraries and the REST libraries by going here into my IDE and actually using the NuGet package manager, right? So we can actually install complete libraries through NuGet, which is what Chocolate is based on, right? So we have those libraries. We reference, besides the JSON and the REST libraries, we reference the system management automation to get the PowerShell business out of this, okay? And then we create an object or class. We inherit from the commandlet class. This gives us a commandlet that we can now have complete flexibility in how we build that, right? This is the verb noun format that we always see in PowerShell. So invoke REST Puppet DB. That's how you specify what the name of the command is going to be, how it appears when you import it. Some basic, class setups. The parameter is only one in this case. They're very straightforward. Now, this might look familiar to you guys. If I collapse this, what does that look like? Anyone?
The begin process and end block.
You got it, right? So PowerShell, the begin block, the process for the pipeline, and the end for the end of processing cleanup that you want to do. So when you inherit this object, you get these for free, kind of populates it for you, and then you put in here the code that you need to do for the begin part of it. Okay, in this case, I'm doing some parsing on the URI. For the process record, each one of these you have to call the base constructor. This is just object-oriented programming in this case. But I create a REST client. I pass it the URI. I have another class that I wrote that just has the parameters, right? Not a real fancy one. There's no methods here. It's just a bunch of properties for the class. That's important though, because down here is where I actually call the REST API, and I take all those responses and I create an array of Puppet objects, or not necessarily Puppet objects, but responses back from my API, and deserialize those, and then I can write them right back to to PowerShell at the command line. So this actually returns a PS object, and it has all these in here for me, and it's consistent every single time. Yes, Luda?
I use this for performance reasons?
I did this because what I found was the response I was getting back for 2 meg and larger responses, I wasn't able to handle it, right? So my next, actually one step I missed, I tried to actually call some .NET in deserialization with JSON in PowerShell. The syntax got really, really ugly. I've done a little bit of C# in the past, so I was familiar with it. It was actually easier for me to express it in C# and .NET versus trying to write the syntax in PowerShell. Speed, I didn't really do a speed comparison because I never got to work with just PowerShell except for small ones, so the speed difference is probably not detectable. If it was better or worse, I don't know. But I found I was excited with this one because it let me do what I needed to do and kind of opened up a world of being able to use another tool to create more complex PowerShell tools.
Okay, very cool.
And then in this case, the end doesn't really do anything here. It's just calling the base constructor for the commandlet class that we inherit there. Okay. All right. Okay. Any questions, folks? All right. Guess we have some time. We'll cover a little bit about PowerShell workflows. So when I set out to use this, anyone here use PowerShell workflows in the past? Probably because they're really strange, right? I mean, I avoided them for a long time because they're really strange, and like, why would you use those? And it's too steep of a learning curve. It's like I don't understand it. There's PowerShell. Some PowerShell doesn't work in it that I'm used to using. And there's probably about 500 different blogs out there as to when you should and shouldn't use workflows. Okay, so I tried it, and there is some practicality to it. So workflows in general, what makes it kind of strange, I think, if you're really used to PowerShell, is it's PowerShell. You're expressing a way to do something in PowerShell, but what you're really doing is that gets converted into XAML, right? XAML. I don't think I have an example to show you, but it's really ugly, and it's used by the .NET Workflow Foundation, I believe, right? So you feed you write PowerShell to express it, generates XAML, then it feeds into the workflow engine. What intrigued me about it was that I'm used to, in plain PowerShell, handling things like job management myself, right? And there's many different techniques you can do to handle that. Spin off as jobs on remote boxes, wait for the jobs to return, run them as jobs. You can create a bunch of connected sessions, right, and manage those and keep doing things over those sessions. But you get a lot of that for free with workflows. But there's, and free probably, there's a little bit of price to pay. But you express it in a way that lets you specify what you're going to do on one single computer, and then you ingest it and say, do this on a bunch of computers, okay? And it handles sort of the instance of it running on a bunch of different boxes for you, okay? Not some of these are actually some PowerShell commands have been in 3, right? So workflows is available in PowerShell 3. Some of the PowerShell commandlets work directly with workflows, some don't. But it does provide a way, PowerShell provides a way for you to actually use non-workflow commandlets in a workflow. Okay? So I'll just jump to this one. That's the one I'll use. Okay. So you have this this construct of a workflow, right? So that kind of replaces the function keyword. I don't want to say replace, it's probably a bad way to say it, but it's kind of in the same place where a function would go. And you define here parameters you might pass into the workflow, any kind of code you're passing in. I'll step through this in a little more detail. But one of the key things is you can run through your loop here. There's a parallel option that's produced, or not produced, but provided that you can specify this. So it's really a for each loop. But it's done in, if you look at this, once I do this, I don't really need to manage much about the remote management of that. It just does it for me, okay? And if you have some PowerShell commands, commandlets that don't have workflow ability, there's this inline script construct that you can use. So workflows, if it's, one of the things that's hard to wrap your head around at first is that you're used to, in a script block, in an entire script or a script block, when you execute something, there's some kind of state that's kept from line to line that you can leverage. That doesn't happen in workflows. So that's one of the hard things about workflows you have to get your head around. So everything you run runs as a PowerShell isolated process, and in order to get information out, you sort of have to pass it back and then go to the next one. Right? So it's a little kludgy that way. So a general pattern I did here, and I probably would have done it a little bit differently later on, but this tool was written. So anyone here use MS Deploy in their environments or anything? Lou from Bill. So MS Deploy, it's a great tool. I'm using it here. But every time I reset the environment, okay, I have a snapshot of my IIS web server, which includes all the configuration, all the files, okay, and I have it exported to a zip package. And then I want to sync it back. I just run it, and it syncs everything back, right? So you can use that to do things like, I have a new server I want to configure. I have the base requisites down. Now I can push everything here to here. So it's nice syncing. It's a great Swiss Army knife tool, and it comes in handy. So in our case, you know, we had a need for that, but MS Deploy, it's kind of one-dimensional, whereas you specify a source and destination. But if you had 100 servers, 200 servers, 800 servers, one at a time, right? So I use workflows here to get a little more parallelism out of it. And the general way this whole piece of the PS deploy works, wrapping it around MS Deploy, is we have an image, and we store it in one of our repositories, and then we use this tool to issue a command to all the servers that we want to do. And it goes out, they're all doing in parallel, grabs the image, brings it down, then runs MS Deploy all synchronously. Well, asynchronously really, right? But they finish roughly the same time, right? That prevents us from having to do one at a time, right? So that's the overall concept of this. But back to the technique of the workflows, you know, there's some scripts here. At the time I did this, I used a here string because I wanted to be able to define an entire script block. I'd probably do this a little bit differently now because I'd probably call the script block parameter and then have it syntax highlighting in the code. But this works the same way. So I define a block of code that I'm going to run on a particular server. Doesn't matter which one. I can even put output here. This code, I also have options here to, if you want to do a backup of the server before you do it, it actually creates a MS Deploy copy. It syncs it to a local disk so you have a backup of what you're going to overwrite before you overwrite it. And then the script to actually copy it over. There's some ancillary things here. We actually do some validation of if you specify a URL where you want to download that script, it actually does a verification before it goes to download. It'll tell you, or it's not going to go through all the step, all the process, and then fail miserably. It actually, it's a pre-check. And what was interesting about this one was we found out, actually, the gentleman in the back there found out that on a sufficiently large package, it actually had a problem. I was using the invoke web request method of PowerShell, right? Kind of like this in HTTP GET. And it kind of bombed out. There's actually a Connect, Microsoft Connect, there's actually a bug for this. So the workaround was to borrow from our .NET friends and use a web request object and just use it, you know, set a head method and get the request and basically find out it's okay, right? So the head request doesn't get the entire thing, it just checks the header, and if it's a valid URL, you're going to get a 200 response back, right? So it's a cheap way of checking to make sure that's a valid URL that you're using. You haven't fat fingered it. And then once you go into the, so that's the workflow here. This is what does it. I take the script blocks and we scroll down a little bit. We create a script block object out of it. And then we essentially pass that as a script block, and we pass in some parameters. Another thing that you may be noticing here with workflows is this using keyword. Scope becomes very important. You don't really normally deal with that in PowerShell too much, right? Unless you have a very large script, but the scope of where it is relative to the workflow matters. So there's some additional keywords that are included here. So you can use something that comes from a different scope within the workflow itself. And then the final thing I think I'll show you on this one, and this isn't necessarily a proxy function directly. Anyone here use or hear of proxy functions? So you have a PowerShell script, right? And you have your begin process and end blocks usually. I saw someone do it with a write log function, which essentially enhanced the out file commandlet. Out file can dump to a file, right? So someone wrote a tool that created rotating logs. You can specify, I want 5 logs, no more than 5 logs, each one being no more than 10 megs, right? So a nice log rotate function. And he created a script which took in the parameters and then mapped the begin, process, and end blocks to the out file, right? It's a little bit hard to get your head wrapped around at first, but it's an interesting technique. If you look if you search for it on the web, you'll find a few blogs on that and how to use that. It's a really helpful technique if you want to extend functionality. You say, I wish this commandlet did this. How do I extend that, right? Do I rewrite a whole new one to do it? Or no, you can actually use that and then kind of front end it with some additional functionality and then leverage that and call it, right? So this isn't really a proxy function in the true sense of the word, or proxy script, but this technique here is used oftentimes in those proxy scripts, which is examining your parameters, right? So you're in the script, and what I'm doing here is we have a wrapper script around it that I ingest parameters and I do a few things I check, and then I actually invoke the workflow after I do this pre-process check. So in this case, you're able to access the parameters through the PS-bound parameters built-in object, okay? And they're basically hash. It's a hash, right? So you get a key value, set of key value pairs, and you can, specify if it's there. In this case, the prime example here is people are specifying, users are specifying an HTTP URL as a string. But I want to pass that as a URI object to my workflow. I want to convert that. So I take that, okay, and I remove the packet source path from the original parameters I'm going to pass in, okay, because that's a string in this case. It's a different object, really, okay. I'm going to convert that into a system URI, which is a .NET object, and you get an object that has all these properties you can access about the URI, and I use that to validate. And then I basically add it back to the parameter set, but I add it as a URI object because then I can pass that on as a URI object. So I extract the string, convert it, poke it back into the parameters, and then this here calls the workflow, okay? That's called splatting. So PS-bound parameters, you have a bunch of parameters. It's actually, when you reference it that way, it becomes a hash table, so the key value pairs. And you pass that in, and when this calls push config, which is a workflow, which is the actual workflow, it lets you have a little more dynamic nature of managing your parameters. Fortunately, I can't run it here because obviously I need a big infrastructure of devices to run it. But just a few different techniques within that to share with you guys. So the nice thing here, one more thing I'll mention, the try catch block around this. When you do it at this level, it's nice because if one machine happens to fail, it won't fail the entire workflow. That one will fail. Just like normally when you have an error that runs, right? You use your error action. You set that. PowerShell typically continues on, and you have an error in one and continues on with the other. So this is kind of the same concept at a workflow level. Just using standard error handling. Okay. Any questions before we wrap it up? Okay. So just kind kind of let's review what we learned. The goals I had here to share with the group, you know, some of the similarities and differences of Puppet and PowerShell, just as a basis, right? So you guys can see how Puppet works and put it in the context of DSC. You know, and this goes for not just Puppet, obviously, but if you're in DSC, you know, look for a module that someone else may have written. Try to incorporate that. If not, you know, roll your own. In the Puppet side, we saw how we could use a few different PowerShell techniques to extend it, make it a little more usable, write our own tools with our own config management modules. And maybe some of the other techniques that we saw here, you know, were helpful. Maybe hopefully you guys learned something. And anything else you guys saw that was interesting? A lot of stuff, I know. It was a pretty dense presentation, I think, with Lita.
So just a question for you. How is DSC made life easier with your Puppet configs and stuff? Or are you getting away from the inline and transitioning everything towards DSC? Or?
So in our case, I'm still exploring how to better integrate those. So this is more of a starting place for DSC and Puppet. You know, there's features in both that are really attractive, and in some places you may not have an option to use DSC. You may have, you know, maybe you're only using Puppet, or maybe you can only use DSC and not use Puppet, right? But I'm trying to explore that. So I would say right now for us, it's kind of the beginning of exploring that mashery a little bit. One thing I will say, I'll also add to that, right? The concept of idempotence in either one of those, when you execute the DSC itself is idempotent if you build it that way, right? So if you write that module, and you have those three components, itself it is idempotent. From the perspective of Puppet, you're executing it every single time. Okay. So the reporting may get a little skewed because if it's purely idempotent in Puppet, Puppet knows if it ran something or not, right? So you sort of mask that a little bit from Puppet when you do the DSC. The end result is the same, but the reporting may be a little off from the Puppet perspective. Anything else? Good. All right. Thank you.
Thank you very much.